Okay, review over logarithms and exponential functions. So this first part's pretty easy if you remember how to do it. Log base 6 of 216. To find the answer to this, you put equals. And pretty much what you have to do is take your base 6 and multiply it till you reach a product of 216. That's 36. So it's not 2, answer can't be 2. How about if I add a third factor of 6? That's 216. So that's it. So that's 3 6s. So 3 is the answer to the problem. Okay, now this one right here, same idea. The base is 5. I'm trying to multiply 5s till I reach a product of 625. Well, obviously it takes more than 1. 2. Okay, that's 25. I got to get 625. Is 3 enough? Nope. How about 4? Yep. So, that is 4. Okay. Okay, now my next one. Base is 11. There's 1. 2. What's 11 times 11? 121. So that takes 2. The answer is 2. Okay, now we're going to ignore the fact that this is 1 over 27. We're going to put a negative, okay? And we're just going to now call this, just put a regular 27. So I'm going to multiply 3's out till I hit 27. So 1, that's 9. 9 times 3 is 27, so it takes 3, but it needs to be a negative 3 because I reciprocated it. That's when you have 1 over the number, but then you just make it a whole number, and you're going to need to remember that too. Okay, now we need to solve these equations for the x variables. Find what the x is equal. Now, you'll notice how it's not 8 times x, it's 8 to the x power. So I put a little power symbol, and then I circle it and split it, okay? Because there's a formula I know that can find the x for me. And by the way, you can't multiply 8's out till you hit 314. You'll never find it, okay? So I know that formula is taking the exponent, just x this time, and setting it equal to the log over log formula. And I know the bottom log right away. It's 8, okay? And do I have any multiplying number out here? I don't think I do. So I can go ahead and put 314 on top. As long as there's no multiplier out here, that's good. Okay, so I'm going to take the log of 314 and divide it by the log of 8, and I get 2.76. So that is my answer for x. Okay, my next problem, again, I see x as the power. Don't take 7 times 3, none of that stuff. Put your power symbol and then circle the power in its base and split it in half. So you know that you can use the formula 3x is equal to my log over log. Now in the denominator you always put the base, 7. Again, I do not have a multiplying number here, so 18 can be placed on top, okay? So we have 3x. We're going to have to divide by 3 after we find this here. So log 18 divided by the log of 7 is 1.49, okay? I don't really care how it's rounded. But then unlike here where it was just x, you're going to have to divide by 3 after you do your change of base. This is called the change of base formula, okay? So 1.49 divided by 3 is that'd be 0.50 or 0.5, okay? Okay, now the next one. Next one's pretty annoying, okay? Because we have an x power and it's on both sides of the equation. So I do the same thing, but I'm not in a position where I can use my log over log. Now, if this wasn't here, I could, okay? But we got an exponent there. So we're going to use the swaggy sunglasses here. And I put the two bases, 7 and 49. Now, I would be really cool if these were both 7s, okay? So how many 7s would it take to multiply to 49? 1, 2, I think that's 49, 7 times 7. So I'm going to replace 49 in the equation over here with 7 to the second power. Now we want to keep that the same. Okay, and then the 49 is replaced with 7 to the power of 2. Figure out how many 7s it takes to multiply to 49. You can rewrite 49 as 7 to the second because 49 and 7 to the second are the same thing, okay? But then we need to put a parentheses in the exponent that was originally with the 49, 2x plus 1, okay? And what I can do now is I can cancel the bases and forget them as long as they're the same. So on this side, we still got 3x plus 4. On the other side, we need to distribute 2 to 2x and 2 to 1. So that's going to give me 4x plus 2. Now, it's a nice simple linear equation you can solve, okay? Your x's are to the same power. Pick one to get rid of. Let's deal with the 3. No, you don't need to get everything to one side, okay? So we have 4 equals 1x plus 2. And then I minus 2. 2 equals 1x. And then I can divide by 1 if I really feel like it. 2 divided by 1 is 2. So remember, if that x power is on both sides of the equations, we're using the swaggy sunglasses. And what I'm trying to accomplish is to get the larger base to match up with the smaller base. Just figure out how many of these things it takes to multiply to this. Okay, 7 to the second. I go from there. Okay, now everybody's favorite, everybody loves graphing, okay? So y equals 4 times 3 to the x power. You don't say 3x, it's 3 to the x, because 3x means it's 3 times x, and it's not. It's 3 to the power of x minus 5. So there's no domain restrictions, okay? So I'm going to do 2 through negative 2, but I got to know where to start. Well, my base here is 3. 3 is a whole number, so I start with the positives, okay? So I end with the negatives. So to discover my asymptote, I use my negatives, because any exponential function with a power is going to have that asymptote line, ASYMPTOPE, okay? And then I start plugging in. My exponent has no operations, it's just x. Now sometimes if it's like x plus 2, you get rid of the plus 2 and you minus 2 to all these after you've calculated the y's, but that's not going to happen. I was nice on this test. So I take 4 times 2 to the power of 2 and I get 16. I take whoops, I did that wrong. 4 times 3 to the power of 2 minus 5. I got 31. That's wrong. Okay, 31 is the output. Okay, now swap out your second power with the first power, and we're at 7. I go to your power. Power is 1, but now I want it to be 0. By the way, it's not 1 all the time because you have other operations. If it's just 3 to the 0 power and that's all you had, it'd be 1, but not here. Okay. Because it takes the 1 and times it by 4 and subtract 5, I get negative 1. Okay, now reset. 4 times 3, power negative 1 minus 5, and I get negative 3.67. Okay, then swap out your power of negative 1. Instead of power negative 1, you want negative 2 now to go in for that power. Okay, negative 4.55 or 56. Okay, then we're going to discover our asymptotes. Okay, 4 times 3 to the power of negative 20, and then subtract 5, and you get, that's really close to negative 5. Now let's say I go all the way to negative 30, okay? So the asymptote's negative 5, and that makes sense because the asymptote's whatever's added or subtracted behind your power, okay? Okay, so I'm going to need to go by fives here to make it to 31. So first I go down to -5. So 5. Don't go 1, 2, 3, 4, 5. You're counting by fives, so down. And I can't cross that line. They might be all up here. They might be all up here. Okay? And what I'm going to do is just graph the first 3 points. 231. So right 2, 5, 10, 15, 20, 25, 30, 31. Okay, 1, 7, right? 1, 5, 7. 0, -1. Remember, you're going by 5, so you don't want to go down here. Okay, -1's here. Then you know what's going to happen. You go infinitely upward as x approaches positive infinity. And as x approaches negative infinity, all that happens is you get close to the asymptote, but don't cross it. Okay, looks like a fishing hook that somebody mangled. Okay, and now we have story problems. You buy a boat for $4,000. The boat decreases in value by, and also down to, I want you to write something here. When you're finding a percent, you need to -1 times 100, okay? I will have that on the test. You buy a boat for $4,000. The boat decreases by a constant percent per year. After 3 years, the boat is worth $3,217. What percent is a boat decreasing by in value each year? So my significant units, as spotted, are dollars and years. So X is years, Y is money. So per year. There's no dollars per year, it's a percent per year, so that eliminates the line. Okay, you're not going to make the line. You're going to write the exponential function, but I don't know the percent, so it's P. So I set up my exponential growth, blank times blank. That blank gets a power equals blank. Now remember what these all mean. This is the original price. This is the percent. This is X, that's the years. And it doesn't say quarterly, so I do not put a 4 there, okay? You don't see quarterly anywhere in there. And then new price. Okay, so the original amount's $4,000. We don't know the percent, that's P. X is years. We know the X, and we know that's third power. And $3,217 is your new price. Okay, so I'm not using log, okay, because I know everything about the power I need to know. I know it's 3, okay? So we're solving for P. We need to write that out, 4,000. P to the power of 3 equals 3217. Okay, then I need to divide out the 4,000. That leaves me with P to the power of 3, and this is always a decimal. 0.880, and then I find the cubed root, okay? Put a 3 in the index. So 3 second, 0.80. Whoops, sorry, my bad. Okay, now don't write that answer down. You got to subtract 1 and then hit equals after you do each operation. And then you're going to multiply by 100. So that's -7%. You can put -7 because that makes sense. It's a decrease, so it's going down by 7%. That is how you solve for P. You don't use logs to solve for P. You know the P is not the power, okay? It's when I use log over log if I don't know what this is, okay? That helps simplify. Okay, number 9, you deposit $500 in a bank account that earns 3% interest each year. How long, and I cross that out, I don't want that. How long will it be before that account reaches $1,000? So, we have dollars and we got years. X is years, Y is dollars. So per year, there's no dollars per year, it's a percent growth per year, and it's 3%. So now that I know the percent, I write 1 down, and I divide by 100, but I don't need to divide by 4 because it did not say quarterly. So I divide 3 by 100. That's 0.03. You guys got to watch out for that. And that'd be 1.03. So that's my percent factor when I write this. blank times blank to the power equals blank. So again, we got our original, and that's always the Y unit, then percent, and the X unit goes here. Now, did I see quarterly? I did not, so it's just X, no 4. And then new. Okay, the original is 500. Percent's going to be the 1.03. X is years. Oh, I don't have the years, so now I will use a log over log. And the new ends up being $1,000. Okay, so I take that X and I set it equal to my logarithm ratio. In the bottom we have 1.03. Now, don't put 1,000 because we have this 500 here that we need to divide. Okay, and 1,000 divided by 500 is 2. Okay, so I take log 2 divided by log 1.03. Gives me 23. Okay, so X equals 23, so it takes 23 years. Okay, and last problem. I deposit $300 in a savings account. The account's going to earn 5% interest each year, compounded quarterly. Which money is going to be in that account in 12 years? Dollars in years. X is years, Y is dollars. So per year. Okay, there's 5%, so that's a percent. Okay, so I ain't drawing the line. If it was $5 a year, I'd be drawing the line. Okay, but I'm not. Okay, so I know what I need to do. I write 1 plus, because it's going up, interest goes up, then divide by 100, and you also got quarterly. So you also then need to divide by 4. So 5 divided by 100, and then divide by 4. So you'll be adding 0.0125, and that is 1.0125. Now I'm ready to roll. Last problem, I didn't divide by 4 because it was not quarterly. So again, original. I'm talking about the Y unit. And then it's multiplied by a percentage. And then X is the power, but, oh, it said quarterly. Put the 4 in front of the X. Not in for the X, it's 4 times X. Okay? And then the new. Okay, so the original money's $300. And my percent is 1.0125. Now, X is years, and I've got 12 for that, so please take 4 times 12. It's not 412. That's 48. Okay, now the money new I don't know. I know its original is 300, so I put Y. Now, do you see anything happening to this Y? Are there any numbers over there with it? No, there's no operations. You plug that in to your calculator. I take 300 times 1.0125, raise it to the power of 48, and that would be $545.